Figure 2 shows ABC, a sector of a circle of radius 6 centimeters with center A. Given that the size of the angle BAC is 0.95 radians, find the length of the arc BC, the area of the sector ABC. The point D lies on the line AC and is such that AD equals BD. The region R, shown shaded in figure 2, is bounded by the lines CD, DB and the arc BC. Show that the length of AD is 5.16 to 3 significant figures. Find the perimeter of R and the area of R, giving our answer to 2 significant figures. So let's have a little look at this then. I've got the question summary here. Part A is arc length of BC. So part A then, arc length. Probably put it up here is better, isn't it? So part A, answer then. For the circumference of a circle, it's 2 pi r, and that's a nice memory aid to remember the angle. 2 pi is a whole circle, isn't it, in radians? So from that you can get arc length is r times the angle in question, r theta. So arc length is r theta. So let's put that down then. R is 6 times theta, which is 0.95, which is equal to 6 times 0.95, 54, 57, 5.7 centimeters. Okay, good. Tap it in the calculator if you need to. Find the part B, area of sector. Now the area of a circle is pi r squared. That's a whole circle, of course. If you write that as a factor of 2 pi, you'd have to put a 2 top and bottom. Here's the full circle then, that's the area of the full circle. So the area of a sector of a circle will be r squared over 2 times theta, or a half r squared theta, isn't it? So part B then, a half r squared theta. So let's put the answer to be here. Answer equals a half r squared, so that's 6 squared, times theta, which is 0.95, which is 19 over 20. So you've got 36 over 2 here. 6 squared is 36 over 2, and this is 19 over 20. So we could work it out by hand if we wanted, rather than use a calculator. This is 18. Then there's a 10, and this is now a 9. 9 19s, 161, 90 and 81. 90 and 81 is 171 rather, divided by 10, which is 1.71. And that's centimeters squared. Okay, that's B done then. Now C, show that the length AD is 5.16 to 3 significant figures. So this length here is the same as that length there. Okay. So, yeah, what we could do is drop a perpendicular here to this side here. So I'll just do that by sketching it in the diagram. This is a right angled triangle now. This, because this is an isosceles triangle, this side will be 3 and this side will be 3. So we need this length AD, don't we? So we got SOHCAHTOA. Let's just do it here. We've got the sine, cos and tan of the angles. And then we've got the adjacent to the angle here and here. And we want, what do we want? We want the hypotenuse, don't we? So we need to use cosine. So let's do that then. Cos. So cos of 0. So that was just a little reminder. So cosine of this angle then of 0.95 is equal to the adjacent, which is 3, over the length AD. So that tells us then, move the AD up here, and then the 3 can stay as is, and move the cos 0.95 underneath. So let's type this in the calculator there. So we need to be in radians mode. So let's go into radians mode, number 4. And now we do 3 divided by cosine 0.95 equals 5.16, isn't it? To 3 significant figures. 5.16. And that's to 3 significant figures, which is what we wanted. Find the perimeter of R. Now the perimeter of R will be this length here, BD, and this arc length here, and this distance here. Okay, well we know this distance is just this distance AD. AD equals BD, so arc, so we've got, what have we got then? Let's write it down. D answer is equal to, so let's have a look then. It's going to be length BD, which is the same as AD, and we've just worked out AD, haven't we? 5.16 plus, so that's that side, arc length BC, which was the first thing we did, which was part A. Part A was done up here, wasn't it? 5.7 plus the little bit of distance between the 6, take away this distance here. So it's plus 6 minus the 5.16. So these cancel. We've got 6 and 5.7, which is 11.7 centimeters. Okay, that was D. This wasn't A, this was C here, wasn't it? Better put that in properly. And then E now, the area. Okay, the area. Okay, the area will be the area of the sector, which we've worked out before, part B, and we got 1.71. Yeah, half BC, half R squared theta, wasn't it? 36 over 2. This doesn't, 19 over 20. This is 17 over 10 is 17.1 here, because I've just decided to divide by 100. So let's just change that now, 17.1. Okay, so that's adjusted now, thankfully. Now we've looked at this problem. And E, we need the, so it's the total area, which is 17.1. Area R then is equal to 17.1. Take away the area of the triangle, which is a half, BC, which will be 6 squared, times the sine of the included angle, sine of 0.95. Half BC sine A. Just look at the picture. Half BC sine of the angle. And that will be the area of the triangle here, which it isn't that, is it? B times C is 6 times this distance, which is 5.16. So it's 6 times 5.16. So we need to put a 5.16 in here as well. I'll put it at the end. 5.16. So let's work this out then. Quite a few little glitches here, but we've checked them as we've gone along. 17.1 minus, this is 3, times 5.16 times sine of 0.95. Close the bracket for the sine. 4.51. 4.51 centimeters squared, and that's the 2 decimal places. And we needed to work it out, E to 2 significant figures, so it'll be 4.5. So again, let's adjust that now. 4.5 centimeters squared, and that's the 2 significant figures.